All right, we're back. It is COMP123, summer 2016, programming 2, week 4, part 2 of our broadcast. And I just introduced the notion of inheritance, which is creating a superclass and a subclass. Now, we don't create a superclass in this particular case. Our person class had already been created. And all we're doing is we're making it into a superclass by creating a subclass of it. Or, again, this could be called the base class, the person class now. And the student is the subclass or derived class, right? Lots of words for between the same thing, okay? So when I talk about superclass, parent, or base class, I mean the class that any child is going to be derived from, okay? And that's why the children classes, the child classes, are also called derived classes or subclasses, okay? So I've kind of this whole idea of a parent-child relationship. And if you think about that, I can have many children, but only one parent, okay? Not two parents, like how we do in real life. We have two parents. We have a mother and father typically, right? Not so in programming, okay? Typically, we only have single inheritance. It's almost like the person class made itself a clone, right? And that's what it is. And then we've taken that clone material and extended it, right? In fact, sometimes we use the keyword extends in other languages instead of the colon. The colon, this syntax, this is what this syntax is. This colon tells the compiler that anything that comes into the left is the child class, and anything that comes to the right is what the child class or subclass is derived from. So this would be signified that the person class is the superclass for the student. Yes? So the person class, so the student inherits from the person class. That's what it means. Yes?
So if we another class and we inherit the other student, so student will be the master and then that class will be...
Let's do it. Yeah. Let's do it, all right? And this is where it comes a little bit crazy, all right? But let's add some stuff first, okay? So I want to add some more properties and instance variables to the student class to make it unique. Right now, it's almost identical to the parent, the person class, except that it only has one default constructor, which is the empty constructor. Again, one thing that does not happen, just to reiterate, is that the subclass or the child class, call it whatever you want, the derived class, does not inherit the method, the constructor methods from the parent. It does not inherit those methods. The constructor methods is the only thing it doesn't get. It gets everything else, properties, it gets instance variables, it has everything there. One thing to note also is, would I have access here in the child class to the private instance variables of the parent class? Would I have access? What would you think? What do you think? What do you think? Do you think I have access to? So what are the two? I have two private instance variables in my parent person class. What are they? Name and age. Do I have access to those two things, the private instance variables, directly from the child class? Yes or no? No. Let me show you this. Yeah, this is where it becomes confusing, right? Let's check this out. So if I do something like this, if I make a constructor, let's make a constructor. So here's my my empty constructor. This is what this is, right? With one reference, and we'll start off doing some documentation here, right? And in my documentation, if I put in a summary, and I'm gonna do something like this. This is the empty constructor. This is the empty constructor, or empty/default constructor for the student class. Student class, that's what this is. And then I'm gonna put some other comments in here. I'm gonna put some decorators. So at, again, class is student, right? At, that's it. That's actually enough. We'll talk about that. We'll go back to the documentation, see if I can put anything else for parent, what the parent class is. Because we should signify it. If I was actually to do that, again, I'm looking at UEDoc as our constructor, right? The way we're doing documentation. But there's other ways of doing it as well. I'm just using one simple way of doing it, so we're all the same. It doesn't mean that we all have to do this. So here's our syntax. Notice there's a main, there's a class, there's an element, there's a method, there's an event, there's a property, there's an attribute. We talked about this, right? submodule namespace extends. Remember I talked about extends? Extends the base class, right? We can use that extends keyword to talk about what it extends from. So my class is view, and it extends what? The person class, or whatever in our case, right? So we can put extends. That's something we could probably do. And there's other ones we can use too. As long as you're consistent with your documentation, I won't complain. Okay? If I can read it and go, ah, I see, right? I can do that. Okay? Let's talk about this. Oops. So let's go and try this out. So I would say something like this: extends what? The person class, right? Extends person. And I want you to know the word extends, because even though it's not a keyword in C#, it is in Java. It is in JavaScript. In the new ES6, ECMAScript 6, we use extends. And it is in other languages. All right, so please, extends is something to know in other classes. Remember, even though you're learning C# here and the syntax of C#, you're also learning object-oriented programming for the first time, which you can apply to any language. Okay, so please remember that in other languages we use extends instead of the colon. That's what we're doing. Okay, cool. So this is a little bit of a hiccup here. What I want to do is I want to test that theory of yours. I want to see if I could access, you know, the initializer. Right? Remember in the person class. Here's the person class. I have something called an initializer method, right? And the initializer method is called initialize. So if you're right, and if I can access private properties and private instance variables and private methods, then I should be able to do something like this. I should use the this keyword. I should be able to do this, dot, and then I could do, oh man, where's initialize? So if I want to use initialize, right? If I want to use initialize, private in the parent, as an example, won't fly. The only way I can use a private instance variable, so-called, from the parent is if I change the access modifier keyword from private to protected. Protected is like private, so it's private to the class, but not private for its children. So child classes of the parent class, subclasses of the base class, right? Derived classes, whatever you want to call them. I'm going to keep saying these things so you hear the same words over and over again, because I'm going to test you on this thing, on your quiz. I'm going to say, what are the same words? What is this equivalent to this? It's a superclass is equivalent to base class, right? So if I ask you that on a quiz, you know what it is, right? If I want to make that happen, I got to access it, right? Now here's something else. What about if I want to send something, the constructor, I want to use my constructor, right? The base constructor, the superclass's constructor. That might be a smarter thing to do. So my student class is going to use the base constructor. So maybe I'll do something like this. Base, I can use the base keyword. And depending on what I want, I have access to all the constructors. Take a look. Base constructor, I have from a person class, I can do the person with nothing. I can do the person with an int. I can do a person with a string. I can even do a person with a string and an int, right? And this is where we can make our students or our classes use my initialize method by accessing the superclasses method. So I'm saying, hey, tap the superclasses constructor when I actually call my constructor by actually putting this colon in here. So this syntax says, call the base constructor from the base superclass, base class, right? So let's say, for example, our empty constructor, right? I want it to be like the empty class, right? The empty constructor from the base class, right? So I just do one of these. And that means that it initializes automatically. I don't have to call the initialize method. In fact, we should try and limit as much as possible the use of the protected keyword wherever we can, right? Protected is nice, but I don't want to use it. I want to use my public properties as much as possible, right, to give more control for my child classes from my superclass. I want you to think about that. I don't want to leave something open and say protected, because protected, when I say protected, it means it's open. I've opened myself up now. The child has the keys to the house, right? If I use protected. If I make it private, even though they have the keys to the house, they might have the keys to some things in the house, but they don't have the keys to my private rooms. Or they can't access the celebrity directly, the celebrity being the private instance variable. They still got to go through the middleman. It's almost like I have a butler. So it's almost like I'm treating my children as outsiders still, right? You can't talk to me. You got to talk through my third party here, my butler, which is my property, right? That's what we're doing. We say you need to use the public properties, and that's what I recommend. When you build your classes, try as much as possible to follow that method, where you just use the constructor methods of the superclass if you want to access certain methods that are private. Sometimes you have no choice though, and you need to make it protected, and it solves problems. Okay, now that we've done this, that's all I have to do. I have everything here. Once I do this, I actually initialize, because when I call my base constructor, in this particular case is the empty constructor. If you look at my person class, the empty constructor calls the initialize method, so therefore I don't have to do that. It's almost like it triggers or calls the superclass constructor method that I name, right? So to give me control, right? Now maybe I don't want all these constructors. I only want 2 in my student class, or maybe only 1. Let's say where the difference is from my base class to my child class, my student class needs to take a couple of things in here. It needs a name and an age, and it also needs a student number, right? I need those 3 things. So name, right? And again, the name is a string, right? Age is an integer, and a student number is also a string. We'll talk. The string with a student number, student ID. All right, there we go. We also use the base class. Here's the base class. We're passing in 2 things here. We're passing in the name to my base class. Take a look at this. This is the syntax. And I'm also passing in my age, which is age. This is the syntax for that. Now, it might look funny to you in the beginning. When you look at it, you're like, okay, what's going on here, right? It's kind of a big, long thing. It's almost like I'm saying, hey, pass my, and by the way, if you put this on the next line, sometimes you might see it like this. And it's not uncommon for you to see it like this, by the way, right? 2 lines. So you have your method signature, your constructor method signature, and then what you're passing into the superclass. Notice that the superclass call happens before anything else. I can't call the superclass in here. And so it is for many other programming languages. You can't do other initialization and then call the superclass, right, in the constructor. It doesn't work that way. Superclass has to be called first. The superclass is constructor. All right, if that's the case now, in order for me to make a successful student, if I just leave it like this for a second, I got my student ID. I need some kind of private instance variable. So we're going to say private. Here, by the way, let's do some annotations here. We'll say like this. We'll say private private instance variables here. Right, these are where all the private instance variables will be, right? And up here, we're going to say private, and we're going to say underscore student ID, right? And what kind is it? It's going to be a string type, right? That's what it is. Now here's the question: does the parent class have access to my child class's private variables? And the answer is no. Anything private is private. They don't share it with anybody. All right. Okay, this is my private instance variables, and then I also want a place for anything public properties. I go here, right, in my thing, and I want to make a public property based on my private instance variable. Let's do it by hand, right? And again, I'm going to use the shortcut built into C#, which is prop. If you go prop and then tab, it's going to make a private property, or sorry, public property. I'm going to make it a string type, and it's going to be called student ID with a capital S, student ID. Right? And what I want, instead of a getter setter, I don't want that like this. This is the kind of the quick way of doing getters and setters. Remember I said that this is kind of useless for us, right? You can do it, certainly, if you don't have private instance variables. But I do, and what I normally would do is, let's do this. I want to do something like this. I want to put some curly braces at the end of these. This one. Here's my getter, and as an example. And here's my setter. Right? My setter. So I got my getter and my setter. And for my getter, remember, I got to get the information and pass it out. So I'm going to say something like return, right? And then this dot underscore student ID. That's what the getter does, right? And then from my setter, it says this dot underscore student ID is equal to value, which is a keyword that's whenever I pass something into my setter, the value of whatever I pass in gets passed into my student ID. Same idea here, right? So private instance variables, public properties. I'm going to test you on this. I'm going to ask you, what's the common way? Private instance variables, private properties, public methods for accessing certain things. Okay, cool. So that's my public properties. Let's make a section here as well, just from a documentation perspective, that's going to say constructors, right? Because I'm going to have a constructors area where I have all my constructors. I want you guys to keep organized with your class construction, right? When you develop your blueprint for your class, I want you to keep organized like this, so that way you, for yourself, not just for me, but for yourself, so everything's organized. Okay, I have one constructor, which is, this isn't the empty constructor anymore, right? This is a constructor that takes two parameters, right? And by the way, this is not class student. This should actually go, it's actually method constructor student, and it doesn't just extend the person class. That's not what happens here. It does actually extend person, but it extends the person that also takes two parameters, right? It takes two parameters. What parameters does it take? Well, it takes the string type, which is a name, and it takes another parameter, an int, which is age, and a new one, another param, which is a string type, which is student ID. There we go. So those are the three parameters it takes for a little constructor, and this is not the empty constructor. This is, this constructor takes three parameters: name, age, and student ID. Right, that's what it needs. Let's leave that like that. I can name my class. That's what I wanted to do. See, I put the documentation in the wrong place. I'll be okay. I'm sick. Give me a break, right? And here's my summary. And in my summary, this is the student the student class. This is the student class. It is derived from the person class. And then in my decorators, I can say at class student at extends. There we go. So documentation. Okay, cool. So I've got my private instance variables. I could also go into detail here for my property if you really want to. I did this last time where I kind of documented my property too. So I kind of did one of these for my property. And I recommend you do that. Like for the summary, you want to put something like this. This property, comma, student ID. Includes a getter and setter for the private instance variable underscore student ID. That's what it does. And I can say it as a decorator, I can say at property student ID. There you go. If you want to. What I want to see from you guys is this for your class. For now, your constructor, definitely any constructor, you should kind of document this with what it's for, right? When you do your documentation, it looks like it's a lot of work, but actually if you get used to it, it's part of your workflow, right? If you do it afterwards, some people do this. They just build their stuff and then they document everything afterwards. It's actually wrong. Don't try and do that, right? Because then you might miss something and it doesn't make any sense, right? All right, cool. Well, this is cool, right? I've got a public property called student ID. I want to use it here inside my constructor. I want to say something like this. This dot student ID capital, right? It's equal to student ID, the local student ID that I get from my my constructor method. I don't have to do this for name because it's already done. I already pass in the name and the age into my base class, back to my superclass. So that's already there. So now I have three private instance variables and three properties available to my student, right? I have name, capital M, and I have age, capital A, and student ID, capital S. Those are the three things. That's what makes my student a specialized form of person. Okay, just to extend this example a little bit more, what can students do? What do students have, or they do, a behavior that they have that regular people don't have, regular person. The regular person can do, say hello, so can a student. But a student can do something that a person may or may not be able to do. What is it? Think about a student. Think about the business rules around a student. You're building up this application that defines a student object, right? Eventually. A student can go to classes, yeah? Person doesn't have classes. A person just has a name and an age right now. It may or may not is the answer. It may or may not have classes. Right now, in general, a person does not have classes. A student has classes. It's a specialized form of a person, right? In fact, we're talking about specialization when we come to making subclasses of our superclass, right? So we can do that. We can say attend class, right? We can also have a courses, another instance variable called courses, right? Courses, and each course, right? I mean, I can have different courses that the student can attend, right? So that's one thing he has. He also, well, he or she has a student number for sure. What else does he do? And he studies, right? He or she studies. That's something that they can do that maybe the person wouldn't do because they're not a student, right? Not the generic person. So let's make a studies method, right? Notice that I'm making it plural. Studies, says hello, that kind of stuff. And that's how you should try and think about it. What is the behavior that I'm mapping out here, right? So here is my, we're going to make this our public methods, right? Here we go, public methods. And we'll say it's public void studies. That's the public method. And I'm not going. It's going to be the empty method signature, right? That's what it is. And studies is going to be defined as, when I start defining this thing, is, let's start doing the documentation ahead of time. I'm going to say something like this, summary. This method enables the studies behavior for the student. When I say enables, exactly what I do. When I call the studies method, it starts, the student is studying, right? Okay, keep that in mind because we can get very complex with these examples, right, as we go forward, okay? And also, let's talk about some decorators here at method studies and at returns, it's going to return void. That's not returning anything right now. So method studies, excuse me, returns void. Okay, so let's do a console command. So when I study, this is going to say, this is neat. The name of the student, right? Studies, right? So I'm going to say something like console log, right? This dot name, capital N, because we're using the getter in this case, right? Capital name, this name, right? Plus studies. It's very simple, right? So he's going to be, he or she is studying, right? Okay, save. Notice that I use the name property that belongs to the person's superclass. I have access to it because it's public, right? Like for everything else, right? So I'm not breaking the rules of information hiding, which is part of object-oriented programming. We call it encapsulation. That is the term we use. And so I'm going to test you on this, of course. So we're talking about terminology here. So encapsulation is the idea that we want to put all of our classes in an envelope. We want to encapsulate them in a capsule, so to speak, right? And the only thing we want to expose from that capsule, right, are the public properties and public methods that we choose, okay? Anything that's private is inside the capsule. It's encapsulated. You can't get in there. You can't see what's inside. It's the black box, the idea of the black box, right? Where you don't know the inner workings of the class. All you know is what is exposed for you to use. And right now, my person exposes a few things. One of them is the name property. Another one is an age property, as well as there's other things in here as well. All right. Make sense? Let's test this out. So I've got my studies, and I've got my person class, my student class. I've got to change my program, because notice how I'm getting an error now. My error is the following. If I hover over my student, it says the constructor takes 3 parameters: name, age, and student ID. And then it says there is no argument given that corresponds to the request for formal parameter name of student string int string. That's the only thing it takes. String int string. So it takes a name. So again, this would be Tommy for my student, right? It has an age, 20. Notice I don't have to do the bottom stuff anymore, right? And it takes a student ID. We're just going to make it, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, here's my 7. There we go. Okay, that satisfies the requirement, and now I don't have to do any of this, because that's already been done for me, right? Tommy can say hello, right? He can also study. We're going to do a console write line just to give a bit of space for us. He can also study. Tommy.studies. Okay, studies. So he can also do that as well. Okay. So he can say hello. Tommy says hello, and Tommy studies. Those are the 2 things that Tommy can do, right? Because he's a student. Regular person can't study. It's not a specialized enough form to have that method available to them, right? Let's test this out and see if it works. So Control F5, and then we can see that Tommy says hello and Tommy studies, right? Questions up to this point? So just to repeat what we've done, we have our existing person class. We haven't modified, we haven't touched anything from the person class, but we're using the person class as the superclass of the new student class. We've just created the student class, and we've made a derivation of the student. Okay, here's where we can go a little crazy. I want to make one more. Okay, I've got my student, and I want to make another class, teacher, right, or professor. Teacher is still a person, right, but it's not a student. They don't have the same things, right? Let's try this out. So a person, I have a student, and I'm going to make a teacher. How do I do that? Show me. Tell me the way. I'm going to start asking people so they can help me out. What's the first thing I do? All right, let's do that. So add class to the solution. Thank you for this. Add new class. Here it is to my solution. We're going to call it teacher, right? This is your answer too. So there's different files for every class, right? We don't create a class inside of another file. We create classes in their own files. That's important to know, okay? That's the right way to do it. Okay, here's my teacher. It's still generating on my side. I've got my student, and I've got my program, and I've got my person. Oh, there's the teacher class. What do I do to make the teacher class a derived class of the person class? Okay, so colon and then person. All right, that's the first thing we do. So now let's do some documentation, right? Again, I'm doing the documentation to give you a chance to catch up, right, more than anything else. It's a good practice too anyway. So the teacher class is derived from from the person class. There we go. And we can say something like at class teacher at extends the person class. It's interesting when we say extends, almost like I extend the functionality of my base class or my superclass when I create a specialized class, a new subclass. I extend its functionality. Yes? Well, no, I don't extend from student to teacher, right? Remember, student and teacher on the same level. They're both siblings, right? They're both brother, sister, if you want to call it, of each other. But the person is the parent of both teacher and student. I'll draw this out for you guys in a second, so you guys can see the relationship. All right. All right. So we've got our teacher class. Let's make a couple of things here. What's the difference between our teacher and our student? Well, teacher doesn't have a student number or student ID. It has an employee ID, right? That's what we have, an employee ID. So we're going to make that up. So we're going to say, here is the private instance variables. I'm going to do it all at once, okay, guys? So I know what I want, so I'm just going to create as I go, just to be able to finish today. So here's our private instance variables here, right? And in our private instance variables, we're going to create a new private instance variable called private, and it's going to be of type string, and we're going to make it underscore because it's private, right? Employee ID. By the way, some people might say, hold on, Tom, something's wrong here. You named him employee ID, right? Maybe there should be an employee person, right? Person, and then the subclass is employee, and then a teacher is a specialized version of an employee. Yes, it is. You could go, again, it's depending on how you conceptualize your business rules, right? How you conceptualize the objects that are inside your world, whether it's your game world or your application world, right? In a game, right, we would have a super duper game class. Like, for example, it's called a game object, right? And every other object would derive from it. Well, maybe most objects. Okay, so here's my employee ID. I need a public property. I don't have to have them for each one, but from now, I want to have my public properties here. So public properties, right? There we go. And remember, private instance variables, public properties, public methods to access our class. But we want to still maintain encapsulation, best practices, right? So again, I'm going to type it by hand this time. So we do this. We say public, right? We talk about what type it is. It's a string. We name it. So it's like you use a capital letter for employee ID instead of the underscore, employee ID. And it's our butler, right? Inside the employee ID, we have two things. We have a getter, which returns, right, this dot underscore employee ID. That's what it's going to return, right? We have a getter. And we also have a setter. We go, that also sets the employee ID. So this dot underscore employee ID is equal to value. All the stuff you've seen before, again and again, okay? So we've got our public property. Let's make a constructor that does the same thing. I have my name, my age, but I have an employee ID instead of a student ID. Let's do that. That's a little different. So here's my constructor section. And under there, I'm going to make a constructor, right, which is called teacher. In this particular case, I'm going to use 3 values for the teacher. Name, which is a string. Same idea as last time, right? And I can do integer, which is age. And then I'm going to have my new one, which is a string. And it's going to be employee ID. Employee ID. There we go. When you construct, oops, I added 2 extra brackets for whatever reason, Tom. Why did I do that? There we go. I do want to do this, though. I want to use the base class constructor, right, which is the person class. And I want to pass in the name and the age in there, right, because that makes sense to do. Notice I don't have a semicolon here at the end, because this is still considered the declaration of my constructor. This is my constructor signature. And so, therefore, I don't need a semicolon at the end. All right? In fact, you get an error. All right, then I'm going to pass in my new stuff. I'm going to say something like this. This dot underscore, this dot employee ID, right, is equal to employee ID. Almost did it. Employee ID. There you go. So I'm assigning the local employee ID I'm getting from the constructor into the property of employee ID, which is then passing it into my private instance variable underscore employee ID. That's what's happening. So I always use my butler service, right? And again, because I can do other things in there, right? As opposed to just what I'm doing here. Okay, here's my employee ID. And I need to make some comments here. So we're going to link some comments. And here's my summary. And my summary is, this is a method, right? So this is, for this constructor method takes 3 parameters, and it takes name, age, and employee ID. There we go. And it is at method, at constructor, I'll be okay. At constructor is teacher, right? And at param, again, a string for a name, and at param, an int for an age, and at param, a string for, you see how I'm just duplicating, right? Employee ID, but they're slightly different. They're all different. Right, so we've got a constructor. Let's add a method. What behavior can a teacher do that students typically don't do? Teaches, right? Students study, teacher teaches, you know, or instructs, whatever you want to call it, right? So we can do that. We can kind of make some public methods, break that out over here. And then I'll upload all this to GitHub so you have it all if you can't follow along. So I'm going to do public void, right? And then it's teaches. And what does the teaches do? Well, it's going to bring out something like this. This.name plus teaches. Again, you could be very specific here. You can be more, this could be a more robust example if you want to add other things that it does. But right now, I just want you to learn the basics. All right, so don't worry about how useless this class is right now, because it's quite useless, other than taking in an employee ID. That's all it is, and considering it a teacher, right? So teacher teaches. All right, let us do some documentation so you can catch up. I'll bring this up so you can see it now, right? We're going to kind of do the summary again. This is the new part that we did last week, which actually gives us IntelliSense, and we can say something like this. We can say, this method allows enables the teaches behavior, enables the teaches behavior for the teacher class. Okay, and then of course it's at method, it teaches at return void. Okay, save. Now, in other iterations of C#, if you look it up online, like I said last week, you may see instead of this methodology here, you might see // That's totally fine. If you wanted to use // for your documentation as opposed to this method, you can totally use that. That is the way we use it. We usually do it in C#. Okay, but this, I'm doing this so that way you can remember what we do in other languages. Okay, so make a space here. Save. So I've added two classes, student and teacher. Let's test it, test the class for teacher, right? And for here, I'm going to define a new teacher. So create instance of the teacher class. This is the student class. And of course, we do the same thing. We'll say teacher, and we'll call it someone else. We'll call it Tom. Right, Tommy and Tom. Tommy is the student, Tom is the teacher, right? They're a little older, so he doesn't want to be called Tommy anymore, right? Tommy was the name his dad called him, and he wanted to kill him every time he said it. I'm joking, right? Actually, his old friends still call him Tommy for whatever reason. Anyways, new teacher, and we want to pass him the name plus the age. You see he's much older now, and his employee number, which maybe you have some other digits in here. Let's put in some other digits. So maybe we'll say, just to make it different, guys, we'll say that if you're a student, you start with an S, and if you're a teacher, just from a common way, we start with a T. All right, so teacher, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever the, because it is a string. It's not just a number, right? All right, cool. And now we can do something like this. Tom dot says hello. We can still do that. Notice that Tom cannot do studies, right? I can't do studies because studies is only available to my student, right? So I can't do Tom.studies. I can't do that. See, there is no studies. I can say hello. I can show my age. I can teach. I can do the other things that are built into my class. I can also put in my employee ID and my name, right? Hey, notice that I don't have access, or here's my age. Here's my show age. And I also can put in my age. Those are my properties. Notice that the wrench is a property and the little cube is a method, all right? I don't have access to any instance variables. The instance variable will be like almost like this little rectangle. It will look like a little different than this, like this. This is what it would look like, right? That little rectangle. We don't have that. So, but we can do things like teaches, right? So Tom teaches, there we go, and save, right? All right, let's test this out. So I'm going to do Control F5. And here we go. Tommy says hello, Tommy studies, Tom says hello, Tom teaches. Two different objects, right? Let me add a little bit of between the two just to make it more a little nicer. There we go, save, and let's run that again so we can see a space in there. Tom says hello, Tommy studies, Tom says hello, Tom teaches. There we go. All right, so both different kinds of objects based on the person class. Now remember that both I'm putting it out there to you, right? Tommy is an instance of the student class, and Tom is an instance of the teacher class. But both are part of the person class. They're derived from that. So if I was going to draw a diagram here for a second, just to understand how this works, and bear with me while I do this so you guys can, it's just for conceptualizing this whole thing, right? Just use fireworks here for a second. And you're going to see what the diagram looks like. I'm sure it's in your head. Let's make a new one. So File, New, 64 by 480. And we're going to make a few boxes here, right? We'll make the background of the canvas white instead of transparent. And we'll get a box, and this would be up here. This would be the person class, right? So here's the person class. And when I have my person class, I'm going to draw some lines here. So I'm going to make another box, right? And I'm going to drag it over here, right? It's a different type of people, if you will, right? Here's my person class. Now, this is the relationship they have, right? The person class draws a line. You draw a line from the person class to each of the other classes. And now we just rename what these things are, just so that you can conceptualize what it looks like. This is student, and this is teacher. So here's what we can say. For the properties or instance variables or methods, we can say the person has a method, whatever the method is, right? But when we talk about student to person, right, this relationship, a student is a person. It's got that is a relationship, right? Because I can say that with clarity that student is a person and so is a teacher. Both student and teacher are both part of they come from the person superclass. This is the superclass level. This is the child class or base class, or sorry, derived class level, subclass, all right? Now, we talked about the possibility of making a specialized student called international student, right? That has different properties than a regular student, right? For example, maybe they have another country of origin. Their country of origin would be different than Canada, right? That would be something they have. But then student can have a country of origin too, right? So that can kind of take care of that. You don't want to do too crazy. What else does an international student have that a regular student doesn't have? Other than that they pay more money, right? We don't want to just say that. There's also other things that they have that they, maybe they speak another language. I'm not going to make it, but you can see what's happening. What about another specialized type of teacher? We have a generic teacher. That's very basic. There's two types, right? There's a professor, right? And there's also a regular teacher. So a professor might be a professor for college or university, and then there could be another teacher that's a teacher for high school, right? Or for grade school. Different kinds of teachers have different behavior, right? Maybe the teacher teaches, but it can only teach high school, right? Where a professor teaches college, right? And so we can specialize further as we go through, right? Another great example of this relationship is the idea of an animal, right? A person is pretty abstract. Like, there is no form of function for a person. If I say he's a person or she's a person, we don't know anything about them other than that they're a human being right now. Maybe a human being would be the superclass to person, right? If we were going to, think about that. And then from the superclass of human being, maybe there would be a mammal. Would be the superclass of human being. Almost like we're classifying, like we do in science, right? So a mammal, well, we have a human instead of a person, right? Would be the superclass, a human being, right? And then there's different kinds of human beings, right? There's people who have different jobs, different behaviors, student, and there's a teacher, and then there's maybe a construction worker or a scientist or a developer, right? That could be something else that could be in the same line. Notice that there is no, I can be both a teacher and a student in this example. I can't draw the line between these two pieces, right? Which makes inheritance very, very, I'm going to say this, rigid, right? And this is why you want to be careful when we use inheritance, because we're defining two subclasses from the person superclass. And if I change something in the person superclass, both classes are instantly changed. Yes?
I have a question. If a person inherited from another class called mammal, would student get the attributes and everything else from
Yes.
mammal?
Yes. Just like student gets all the attributes from object. In fact, this is what's really happening. If I was to pull this down, right? Person is actually deriving from another class, like all other classes in C#, called object. So if I was to copy this thing for a second, so copy, paste, put this up here. Oh, I didn't mean to do that, but it's fine. Scale this up. So this is there's another other class up here that's always in effect. It's called object. Right? Object, the object class, is where all other classes derive from. So in fact, a student has the properties and methods of the object class, and so does the teacher, even though it's kind of a couple steps up. So you can have an endless hierarchy, right? An endless inheritance from one to the other. But that means that if somehow C# changed their object superclass, somehow, and if I was using one of their methods by whatever choice I was doing it, I could affect every other class in the library, which is negative. Yes?
There are a few properties and methods in person. Are you going to can we restrict something for student and can open for teacher? Something will be open for teacher but restricted for parent?
No, teacher and student don't talk to each other. Student and teacher are completely separate classes, right? They have no relation to each other other than the person, the parent.
Inside the person, can we restrict some methods for particularly for student or particularly for teacher?
We can, but it's not a good practice. Because that means I would have extra methods I would never use. Like I could do that though. I could make methods that I don't necessarily need to use. Remember, when I derive a class from another class, right? I could have a lot of other methods in that class, as an example, but I may not use all the methods of that class. I think there's a good example up online here, and I want you to, I mean, for some of you are gaming students. Who's the gaming students in the room? I think there's two, right? A couple of gaming students in the room. There's some really good examples of this when we use Unity, right? I'm going to kind of connect it to Unity for people who do gaming. And let's go to Unity. If I was going to go to Unity 3D, trust me, go here with me so you can see this. If I go to Unity 3D and if I type in game object, or if I, game object, right? I looked at that. If I go to Unity scripting API, Unity uses C#, right? Here's an example of some documentation of an actual class in use, right? So we have in Unity some variables. By the way, I want you to think about when they say variables here in Unity, they're talking what? Public properties. That's what these are, right? Because they're available. They're not instance variables. Instance variables, we don't know what the game object looks like back in the, back. Notice that it inherits from object, right? All classes in C# inherit from object. Okay, cool. Now notice that I have a bunch of different variables, like for example, isStatic, layer, scene, tag, transform. All these things are variables, but I want to tell you something, like each of these variables are objects of other classes. This is interesting, right? Here's a constructor, one constructor called GameObject, right? So if I click on the constructor, you can see that it has pretty much one constructor signature, right? Where we pass in the player into the game object. Guys and girls, you should be able to look at any C# class right now, right, and understand how to, what a class is. It's a container that contains things like properties, constructors, and public methods. There's also called static methods. We're going to talk about those a little bit. And there's also some other things called inherited members. We're going to talk about those things as well, right? Well, you can see as we go down that there's a bunch of inherited members. These inherited members come from, as an example, the super duper class, right? Like toString, that comes from our object class, right? And destroy, that comes from our object class too. Instantiate is not something that's part of our our library. And even though it says it inherits from object, if I click on object, right, it says this is a class in Unity engine, right? Object is not the object that we think it is. It's not the object in C#. They've renamed object in Unity. They've kind of created a new API. And the object superclass has other public functions and static functions and variables that it has. But I want you just to be able to see this so you understand what it does. Now, it's great to take a look at a class like this. This is all open for you to take a look at, because when we develop in Unity, make a game, we have access to this open API that we can look at. Like, for example, one that I always use when I create games is the vector class, right? Vector 3. Vector 2 if I want to make two-dimensional games. And vectors basically tell me coordinates, right? They give me things like X, Y, and Z coordinates. That's part of the vector class. Those are public properties that are exposed, right, for the vector class. So I have X, Y, and Z. And my constructor, if I click on my constructor, it can take X, Y, and Z, and they're all floats. That's my constructor signature for the vector. A vector then gives me X, Y, and Z coordinates for a particular object, right? Are you getting it? Classes are blueprints, right? And what we do is we make objects from the blueprints, from the classes. We instantiate them, we breathe them into life, right? And that happens, I'm going to go back to our script here, that happens here in my driver class. When I do use the new keyword, I instantiate or create an instance variable, an instance object. This Tommy is an instance object, right? That's what it is, of the student class. The student class is our own custom data type. I want you to think of it like that as well. We create our own custom data type. It's not a string, it's not an integer, it's a student, all right? And we can use classes like variables or like data types, if you will. One more, and then I promise we'll pause, right, for another break. Actually, maybe we'll keep going, I don't know. Okay, we talked about students and teachers. There's something both students and teachers can use. Someone mentioned it. I want to be able to use something. Students and teachers can both do one thing, right? They're attached somehow to courses. Courses they teach or courses they take. But remember what I said. I can't have a hierarchy, right? I can't have a hierarchy like this. I can't do person, and then if I was to highlight this person here for a second, bear with me, right? So I can't do this. I can't do this. I can't make this courses. I can't inherit from both courses and person. That doesn't make any sense anyway, right? They can't do courses and person. Courses could be a class of its own that also inherits from object, but has its own properties, right? So one of those, there's courses. Okay, so courses has nothing to do with student or person or teacher. It's its own data type. We can use classes like that too. So think about what a course would have. Maybe a course wouldn't have a constructor necessarily, right? Yes? We can have a student have an array of courses that he has access to. Yes, this is where it gets complex. And this is what's called class composition, right? Where I compose my class from different objects of other classes, like we saw in Unity, right? We saw that Unity used classes from other objects from other classes, like for example, the transform class, right? We can transform Unity, right? Move an object from one location in three-dimensional space or two-dimensional space to another one. And we use the transform to do that, right? That we have the transform has a property called position. We can move it, so I can transform the position from A, B, C to, you know, D, E, F, whatever those coordinates are, right? Okay, so we can use other objects of other classes. This is where people get really confused, so I'm just going to put it out there. We'll talk about it again. I don't expect you to remember everything here, because this is where it gets a little crazy. But we're going to continue with these examples. So I want to use courses. I want to have students that have courses and teachers have courses, right? How many courses can you take in a semester? Right, you guys, Nick, how many courses can you take in a semester? Roughly. I mean, you know, within reason. 6? I know people can take 7, 8. You know, some people do crazy stuff, right? And, you know, I don't know how they do it, to be honest with you, but I've seen people take like 8 courses at once or something insane like that. I don't think that's reasonable, but hey, who am I to judge, right? Maybe you have time on your hands for that. So I can have, let's say, 6 courses max, right? Okay, cool. I want to create an object called courses, and I want to add courses into my course array, right? Into my course array. I want to add courses as I want. So a student can add courses, right? I want to add courses. Think about that. First, I need the courses class. I need the courses class. And the courses class is going to have certain properties that's going to be available to it, all right? What are they? Course ID, course code, course description. Those are the things that we can have, right? Let's talk about this a little bit more carefully. All right, so I'm going to create a new class. And by the way, let's while I'm talking, because I know I've done a lot of changes, and I've been going to try and get you guys to get all this information, right? I want to upload this to GitHub. I'm going to go to Team. I'm going to go to Changes. And I've added a bunch of stuff. I added a student and teacher class, right? So I'm going to add that in. I'm going to say added student and teacher class. I probably should have done 2 commits here, classes. And press commit all, right? And now what I want is I want to push it, but I need a container for that on GitHub, which I'm going to create. And so that way you can follow along if you're lost, or if I went too fast, that's okay. Right? You can always watch the videos too to help you. I'm making a new repository here called COMP123, and it's lesson 4, right? For the summer 2016 semester, right? Summer 2016. So there might be other lesson 4s up there too. All right, so there's my repository. I'm just going to grab this and go back here, and I'm going to go to Home, and I'm going to go to Sync. And one day, I'm not going to choose these options here in Visual Studio 2015, just this one where I see this little field here. I'm going to Control V for paste and press Publish. Now you should be able to see COMP123 Summer 2016 Lesson 4 up on GitHub. So if you know my GitHub account, you can go there and get that. All right, cool. So I want to create courses. Now courses have nothing to do right now with students, or they may not have anything to do with students or with teacher. In fact, what we want to call this thing is something called, I like to call, a utility class. A utility class, right? Where I use the class to compose other classes, right? I can make other classes from other classes that I already made. I'm not inheriting, right? You'll see the difference. Inheriting, I need to use this syntax when I go back to inheriting. A student is a, right? It has an is a relationship with person. Is a person. That's how you read this thing, right? A student extends person, the person functionality. Okay. But a student has a course or has courses that he has in his possession. A person may not. A person will not have that. Let's make the course class. And it's not going to be derived from the person class. It's going to be its own class. Let's try this out. Right click. I'm going to go add class. And we're going to call this course. Notice I didn't call it courses. Each course would be its own data type, just like string or integer or float. This is called course, right? Course is going to have a constructor, right? And it's going to have, in our case, we're going to make a constructor. Here's our course class. This is the course class, right? So we're going to make a summary. This is the course class. We are using this as a custom data type. We are using this as a custom data type for our teacher and student classes. Now we don't have it yet, but we will. Okay, let's check this out. Okay, at class course, right? That's important, and it doesn't extend anything. It's its own. Okay, there's another way we can use classes. So one way is we create a class, and then we use that class as a superclass to inherit, right? This is a standalone class or a singleton, if you will, right? The singleton class. And this singleton, this data type, is what we're going to use to create other classes. So let's make a constructor, a public constructor called course, right? And this public constructor, we're going to make one only, just to save time. And this constructor is going to take everything we need. Right? Doesn't have to be that way, but we will. This constructor takes 3 parameters, right? Right? One of the parameters is the course ID, right? What else? Course ID, course code, right? So course code, maybe course code. What else? Show me, help me guys. Course ID. What's the difference between course code and course ID? Huh? COMP123 course ID or course code. You might have like the type of section or whatever. That might be something else. Let's make, maybe instead of 3 parameters, let's make it simple, make only 2 parameters. Course code and description, right? For now, it's for our simplified course, right? Course code and description, course description. Actually, should I call it course code and this course description, or should I call it code and description? Because it is a course code, course description, right? So probably just code and description would be enough. I wouldn't have to call it course code. Okay. Because remember, when we talk about our parameters, it's going to be like this: course.code, course.description. Makes sense, right? Okay, cool. So we have our course description and course code. Let's make those up. So I have 2 private instance variables. So here's our private instance variables. Actually, this is our course constructor. Our private instance variables will be up here. So private instance variables go here. Again, I'm trying to give you as much practice as possible with classes. So when you see them on a test or an exam, which you will, right? And if I ask you to do stuff, the naming conventions I'm using, superclass, subclass, in private instance variables, public properties, public methods, you should know what they are. Constructor method. What's the difference between a constructor method and a regular method? If I was going to ask you that question. There's no trick questions here, by the way. Constructor method? It can. What's the difference? It can't return anything. I like that. It can't return anything. What else? What's another difference between a constructor method and a regular method? Name the same as the class. I like that. That's another reason for, that's another property of the constructor method, right? What else? There's another reason, another thing that we can do with constructor methods, right? Huh? It triggers. It triggers right away, depending on how you create your instance objects, your instance of the class, right? As soon as you use that type of constructor, it triggers right away. It's something that triggers or fires or is called as soon as that an instance of the class is constructed or created. That's why it's called the constructor method, right? We don't use destructors, so please don't ever say those things, right? All right, so here's the private instance variables. We're going to say private. One is going to be code, so underscore code, right? Which is going to be of type, we'll make them all strings, right? String. The code could be a COMP123, right? And then private string, we're going to have to make this description. And then we can make our public properties. Public properties. Right, public properties here. And we'll do something like this. We'll say public string, and we'll call the first one code. And we'll have a getter, which returns this dot underscore code. Right? And we'll have a setter that basically takes this dot underscore code and assigns a value to it. How do I make again, if I was going to ask you this question on the exam, how do I make a read-only property? What do I do? If I make a read-only property, what do I do? What's a read-only property? What's a read-only property? It's a property that does not have a setter, only has a getter. If I only have a getter, that means I can only get stuff from it. If I have a getter and a setter, I can do both reading and writing. Reading is the getter, writing is the setter, right? So if I say read-only property, it means it doesn't have a setter, it doesn't have this. You can leave it out, right? It doesn't have to have both, it has to have one of them. Typically, we don't do just a setter. There is not just like, there's no write but no read. That doesn't make any sense, typically, right? But we do have read-only properties, and read-only properties only have a getter, right? Let's do the next one. So that's our string. Let's do our code. Let's do our public. Actually, let's just copy and paste. It's going to be almost identical. We'll just change everything because I'm lazy. So copy and paste. And we'll change the code from code to description. And we'll change this piece to underscore description. And I'll copy this piece to make it really quick. Copy this one, and I'll put it over here. There we go. So our public properties, I have two. I have code and description. Okay, I need a constructor, and the constructor, these are all the constructors now in here. Constructors. I only have one, but you can have more than one. You can overload your constructor. So at constructor, right? And it's called course. And it takes two parameters, or two params at param. One is it takes a string, right, which is going to be called the course code, so code. And the other parameter is description. It's going to take those two things, right? Which is actually I did it wrong. String. I'll be okay. I'm sick. I can use that excuse just for today. Description. Other days I made a mistake. Again, it would be like this: string code, string description. This is the constructor signature, right? There is no derivation of any of these things, right? And then I can do something like this. I can say, when I assign them, I say this dot description or code. This dot code is equal to code. So the local variable code, which is this one, is passed into the string, the public property code, which is part of the class, right? So I'm actually storing whatever I pass into the constructor into my data. My data is my private instance variables. That's where I store everything, or my fields. They're also called fields, right? Okay, and this dot description, capital D, is equal to lowercase description. And this is typically how you'll see it, guys and girls. Make sense? All right, so we've got our class, and it's called course. That's our class, course. This is all we've got in here. You can see it. Here we go. You guys should be able to do all that. Okay, just to be a little better with GitHub, I'm going to add this to GitHub, so you have whatever I have. So I'm going to go to Team Explorer. I'm going to pin this up here. I'm going to go to Changes, and I'm going to say Added Course Class. There we go. Commit. Home. I'm going to click Home and Sync and Push. There we go. Now, if you go up on GitHub, you'll see my course class. All right, course class, and I have my other two classes, my person class, I have my teacher class, and my student class. Lots of classes, right? Okay, how do I use my course class? How do I use my course class in my student class? Remember, I said I was going to use this as a data type this time around, as opposed to using it in my, I'm never going to use my course class, I'm never going to do this in my person, or my program driver class. I'm not going to do that, right? Now, this is where people get confused, so please pay attention for this one. And then I'll explain it next day as well, all right? So in my student class, I'm going to create a new private instance variable, right? The new private instance variable I'm going to make is called courses, lowercase, right? Let's try this out. Private course, right? Take a look. It's like I'm using it like a data type, right? And then my course, if there was one course, I would just do this, right? But I want to make an array of courses, right? Or a list of courses, right? Actually, a list of courses might be better, right? Now, remember, I don't know if you guys, did you guys do lists at all in COMP100? They're like generic types, all right? So it looks like this. This is the syntax for list. We're going to come back to this again. List, right? And inside list, I put in the type, which is course. Okay, and then I mentioned what the my course is. So list course, right? So I'm using course as the type of list. List is a collection, right? Right now I have no courses loaded in here. It's just a reference to the course shape. What's the course shape? It has two properties that are part of the course and a method, right, and a constructor. That's it. All right? Now, because it's a list, I can do something like this. I can do add, right? But let's talk about this as it's private. We're going to call this courses. So courses is, I haven't defined this yet. The other piece to this piece is if I go new courses, a new list of course, right? And this is where people get confused, right? So when I instantiate my class, I'm not going to create the object here. I could, right? And I'm creating an object of courses. Watch what I'm doing here. It's pretty crazy, right? So if I go here in my student ID, right? Here's my student. Inside my constructor, after I get my student ID, I'm going to instantiate my courses object. Now there's two ways to do this. I can make a public property to do so, right? Okay. Public properties based off of arrays are a little different, okay? And I have to be very careful. In fact, if anything, what I should probably do here at the top is do something like this. There's different ways to approach this problem. Equals. Remember, I can assign and I can declare at the same time, right? So here I'm declaring, here I'm assigning. New list of type course. Okay, and what this does is says, I want to make a new list that holds courses. That's what the container holds, a bunch of courses. Right now, there's no courses loaded into the list, all right? Okay, now I want to make a public instance variable, a property, if you will, of this one. How do I do that? Well, there's a couple ways to do that. If I hover over this thing and highlight it, and if I go to edit, I might be able to refactor, right? And I might be able to, I'm just look and see if I do it. I think I can, oh, there's no way of doing it. Remove parameters. There was a way of doing it in the previous versions, or in, actually I had another version that was called something called ReSharper. And what ReSharper would allow me to do, which is actually an extension you can buy for C#. And what ReSharper allows you to do is, kind of do more refactoring, all right? But for now, let's just make my own method, my own public property. It's going to come under the student ID public property because I want to put them all in order, right? So this is how we're going to do it. Public, what type is it? It's a list of courses type. List of course. That's the type, right? Same as before. And we're going to call this courses. Careful what we do here, all right? So what I'm saying here is my getter, right? Let's see if I can do the same thing. Can I return courses, right? I could do something like this. Return this dot underscore courses. I could do that. That's not going to hurt me, right? So I could get the courses from there, right? Now, it's interesting that I would do this, but it's weird, right? Let me check this out here. And I also have a setter, and I can do the same thing. I could say this dot underscore courses is equal to value. Can't do this. Can't do this, right? It's because my value has to be right, another type of course. I can't just say like my course is equal to another. It's got to be another list of courses. So I have a getter or a setter, but maybe all I need is a getter in this case, not a setter, right? Hear me out when I'm constructing this thing. All right. All right. So courses is of type courses. Now when I load this up for the first time, right? I want to add courses. Well, now that my student has courses that are attached to it, in my program, I should be able to go in here and do something like this. So Tommy is a student, right? And I should be able to do something like this. Tommy dot courses dot, because courses have a bunch of their own methods because it's a class, right? Add, I'm going to add a course. And what course am I going to add? A new unnamed course, right? With two variables, the course code, COMP123, and the course description, programming 2. That's a short description. Whew. So you see that I can compose my class And my class has a list that enables and a list has its own method called add. Actually, a list is an object. That's what it really is. A list is a class that I'm using, right? And it's a generic type class. And I'm using a list. I'm building a list of type course. So the list holds courses. That's what it does. A course that I created, a custom data type that I constructed. Yes. Yes. Yes, but it makes more sense to do this because then I can do something when I access my course, when I do something like this, right? I'm accessing it. But you're right. I could make it a public getter setter without a private part at all. In other words, what he's saying is, do I really need this? And going back to this, the answer is probably not. If I was going to go to students, do I really need to do this with my course? This? Probably not. What I probably need to do here is create a list of courses like this, right? And then this would be, instead of private, it would be public, right? Because it's a reference type. A list is a generic, and it's a reference type. It's not a value type. So therefore, what I'm really doing when I pass into this list, right, is I'm passing the memory location, not the value anyway. That's what he's saying. But I wanted to show you this, as an example, right? I can use the add method that's built into the list type. Don't worry if you don't understand or if I just went over your head, but I want you to see the pattern so you understand how we start composing one class or one course, one object from another. Okay, let's leave it there. When we come back, we'll do more of this kind of stuff and I'll explain further. But this is food for thought. I want to give it to you. I don't want to confuse you. I want to give it to you so you've seen it. So when I use it again, you're like, okay, I've seen what he does there. He's actually composing class composition as opposed to creating a new object. All right, that's it for us for today. And when we come back next day, we'll continue with inheritance and polymorphism.